We're doing a couple of medical demos here. We've got a bone screw, an implantable bone screw, implantable dental implant, and a medical extender. We're showcasing the ST cut, the Milli Pro, the VG cut, and thread whirling. And I have an example of thread whirling queued up, and I'll play that for you now. Here we're just finishing up milling the teeth. This is a self-starting screw. In just a moment we're going to go through the whirling. Here you can see we're turning from 0.4375 to under 0.25 in one pass. The cycle time is approximately 6 seconds and the screw is complete. Here we're cutting off with our VG cut and cutting the top side of the screw. And then it looks like this. Here we're showcasing mock threading and inside Milli Pro thread milling. Here we're showcasing mock threading on the outside, ST cut to turn, and then microscope boring and threading inside. Here we have thread whirling for the outside, ST cut to form this side of the head, the VG cut to cut the backside and cutoff operations, and then the microscope for the broaching in this area.
Hi, this is Dennis Spaeth. I'm with Cutting Tool Engineering, and I am here at the Vargus booth at IMTS 2024 with Ami Yakar, who is the Global Product Manager for Vargus for all things threading.
Yeah.
And he's the guy to go to if you're doing anything with threading, and he's knows quite a bit about the new mock line from Vargus. So can you just start by telling me how long you've been doing this for Vargus?
Time.
What about the whole?
I started my career in Vargus in 1986 as a product designer. Then I moved to the marketing department. Then I became to the product manager of the threading, milling, and turning. And I would like to explain you about the MAC. What is the MAC? What is the big idea of the MAC?
Yeah, tell us about the benefits. And why is it such an innovation?
Yeah, because the MAC, if you look and you don't understand the product, you see it's like a normal insert. When you cut with a threading insert, you make passes to complete the thread. And as much as you make passes, as much as the machining time. So if you want to reduce the cost of the production, you have to reduce the machining time. And that you can do in many ways. Our idea is to reduce the number of passes. So if you can cut the number of passes, you can cut dramatically the machining time and dramatically the cost of the tool. Because most important when you speak about the cost of the production is the machining time. So if you can cut the machining time, you can cut the cost. So what we did here, we designed an insert, totally designed, that we can reduce the number of passes. It's not an easy, because when you reduce the number of passes, you overload the nose radius, which is very sensitive. So the idea is how to make it and not to break the nose radius. So what we did here, we developed a new substrate with a new coating, a new geometry of the rake, and all of this give us the ability to reduce the number of passes, to overload the insert, and not to break the insert. So that's the big deal. Besides this, we also redesigned the clamping system, because when you load the insert, when you have high load on the insert, you may have problem of vibration. Because on the standard insert, all the load are supported by the screw. When we speak about the MAC line, we have a dovetail area over here which support the load. So that's how we can provide a very stable clamping system, and by that we can make the thread in less passes. But you can see the idea of the dovetail. The dovetail is over here. And you have the same on the pocket. Here you can see here. This is the dovetail. You see it's here on the side. You see the dovetail. the insert cannot pop out.
Got it.
It's like a self-lock.
It would never slip out.
Yeah.
Yeah.
If it's perpendicular, it's very easy to take it out. If you have dovetail, it's difficult.
I'm just wondering, why is it 1, 2, 3? Is there? You don't actually mark that on the actual tools, right?
It's comfortable. When you finish the first corner, then you switch to the second.
So they are numbered.
Yeah.
Oh.
Yeah. So you know you finish the first one, then you are working with the second one, and next time you take the insert, you have to start from the second one. Yeah, that's the idea.
You were quite involved in
Yes.
the development of this
Yes.
line. Tell me, what would, before this one, what was the inserter or the threading tools that you might have been a part of?
I can tell you that. Before we innovated the Mach, you have a certain number of passes that you have to take, and everybody used the same amount of passes. It doesn't matter if it's our product or the competitor. Nobody tried to reduce the number of passes because they know the problem of the nose radius. You reduce the number of passes, too much load, vibration, braking, etc. And nobody tried to decrease the number of passes. You see in the catalog, the recommendation, every company that are more or less the same. What we did here, we cut the number of passes by 50%. It's not something small, it's a lot. And even though it's working. And another thing, normally when you overload the insert, the tool life is not so high. Okay, you make the thread, but the insert very quickly become with high wear, and you have to replace the cutting corner. But here, because we totally redesigned the insert, even the tool life become higher and higher, even 100%, even more than 100%. And it was not our main goal. Our main goal is to reduce the machining time, take less passes, and we didn't talk about tool life. We said if the tool life will be the same like the standard, for us it's okay. But then we find the tool life is much, much higher. And for us it was a surprise. So this is the, you call it side effect of the product. That's what happened. I would like to explain that we have the solution for external application as well for internal. This is a tool for internal application. Okay. Again, you see the dovetail and all the features are the same, and you can see the real tool over here. One is for external and this is for the internal. So we have it for both applications. Internal is more tricky because you have to chip flow that should go outside of the bore. While for external it's more easy to evacuate the chips. So it's more challenging.
You have this is the TT here, but
Yes.
you also have the TM.
Yeah.
Is there something that you want to show us?
Yes. This is what we have today for the thread milling, and we have it like two groups with indexable insert, and for the small sizes we call it solid carbide. We made it for one piece, not insert and tool holder. Okay? So this is the standard tool holder tooling we have today for the solid carbide. And again, the idea with the Mach TM is to reduce the machining time. Now here we can't reduce the number of passes because anyway we take it in one pass. What we did with the Mach TM, we didn't change the number of passes because normally we take only one pass, so you can't reduce it. What we did here, we increased the feed of the tool. When the tool rotates around the component, we increased the feed by 100%. And again, the same problem of the nose radius, not to break it, because you overload the tool. So we redesigned the tool, very similar to the Mach TT, new substrate, new coating, new surface treatment, and by that the tool is much more rigid. In addition to that, we had another flute. These are flutes. As much as you have flute, you can run faster. So we had another flute compared to the standard, and we keep we call it the core diameter, the diameter of the tool where you don't have the flute or the teeth over here. This is the core diameter. We keep it as much as possible, the larger diameter. If you have a small diameter, it's very flexible. If you have a big core diameter, it's very rigid. So we try to keep the maximum core diameter. And also, the flute shorter as possible, because when you clamp the tool in the machine, it's more or less up to here. If the flute are too long, you clamp it in a higher place, and then the tool is too long. Long tool is not good because it's have a deflection and vibration. So this is another feature.
Improved on the rigidity of the tool while it's being used. So that there is an improvement.
Yeah, rigidity in this case is very important, because this tool, if it's not rigid enough, you have vibration and deflection, and you may chip the insert. So that's the idea, is to keep it very, very stable. Okay, and you can see it's not the mark over here, but that's the idea of the thread milling. You rotate the tool around the component. So you go with the teeth in and out very quickly.
Slow motion demonstration.
Yeah, this is another tool. This is TMDR. It's a kind of tool which you can drill with the tool, make the thread and the chamfer. Here, when you use this type of tool, you have to drill first, and then this one comes to make the thread. So this is another revolution over here.
Hi, Dennis Faith again here at Vargus USA booth, and I'm here with Tal Rainen, Marketing Communications Manager for Vargus, and he's got some news about their Vargus website, some things to do with the website itself, some updates, and also the e-catalog that has just been released, right?
Yes, that's correct.
So what do you want to start with?
Sure. So Dennis, thank you. Over the past few months, we've gone through a major overhaul of our website, whether it's for global and more specifically for the United States. We have a lot of different things and a lot of information in the website. The one thing that I do want to get your attention on is our electronic catalog, where you can find all of the Vargus products. That includes, of course, you can filter each one of these, but that includes all the actual item numbers, whether you're searching it for by item number, by ordering code, by EDP, and then you get to the product. You can get from this product to the Genius. You can also download the step files, find the related items, whether it's a holder or the other way around, some spare parts, and we've got really all that information up online for you to explore, get to know, and make your life easier when you select the product at Vargus. So the catalog can be reached either from the top menu over here. You can also search for the product, whether I'll type in an item number, or if I go and type in a ordering code, right? I can search any one of these. I can also find it in the menu right here, whether I'm looking for threading, groove turning, right? We're talking about all of our product lines, and we'll be adding products every day, whether the upcoming V-mill and V-drill that we're going to be launching in just a month or so, and all the new products that you've heard of over the past few months. So yeah, be sure to check in. We're constantly changing, updating, and adding more and more data to our product catalog. Thank you, Dennis.
Thanks a lot.
Thank you.